Welcome back, everybody, to the deep dive. This time, we're going international. We're headed to Hungary to check out their Hungarians on Mars competition.
Oh, this is a good one.
It's their 15th annual Applied Engineering Sciences competition, coming up on May 10th, 2025.
I have it marked on my calendar. Not that far away, actually. 184 days, to be exact.
So if you were thinking of competing, well, this is your chance.
You better start prepping now.
We'll break down everything you need to know about this competition, the rules, the challenges, the potential pitfalls.
Yeah, this deep dive will be your guide to conquering Mars, Hungarian style.
So what's so special about this competition? I mean, there are robotics competitions all over the world. What makes the Hungarians stand out?
It's all about practical engineering. They really focus on creative problem solving.
Ah, so it's not just about textbook knowledge.
Definitely not. They want to see young engineers designing, building, operating robots in a really dynamic environment.
Got it. Okay, so walk us through the challenge itself. What do the teams have to do?
This year, they need to build a device.
Okay.
It's powered by compressed air, and it has to launch an object toward a target area.
Ah, I see. So like a projectile launcher.
Exactly.
Yeah.
Then the robot has to retrieve the object from the target area.
So it's a two-parter.
Yes. And the robot also needs to bring the object back to the starting point.
Sounds like a combination of a long-distance throw and like a robotic relay race all in one.
That's a great way to put it. And of course, safety comes first.
Oh, for sure. With compressed air involved, safety has to be a top priority.
Absolutely. The organizers have strict rules about air pressure, eye protection, all the testing procedures. They want to make sure it's a safe environment.
That makes sense. No compressed air mishaps turning into a sci-fi disaster movie.
Exactly.
So what can teams launch? Is there a specific object, or do they get to choose?
It's wide open.
Yeah.
They actually refer to the launched object as something in the rules.
So something.
Yep. They encourage participants to be creative. The only constraint is the weight limit, 250 grams.
So I couldn't launch like a bowling ball.
Probably not, but you could launch something like a miniature glider.
A glider, huh? Interesting.
You'd need to control its flight path very precisely.
Yeah, to hit the target area.
And it's not just about hitting the target. Your robot has to retrieve the object. How would your robot retrieve a glider?
Good point. You'd need a completely different robot design.
Every decision has a ripple effect. You have to think about how your robot is going to interact with your launched object, how it will navigate the obstacles it might face.
Okay, I get it. Open-ended challenge. Lots of room for ingenuity when it comes to the launching mechanism. What about the robot itself? Any rules or limitations?
Oh, yeah, tons. The robot can't weigh more than 5 kilograms.
Okay, that's fairly standard.
But here's a crucial rule. No drones and no pre-built robots.
Oh, wow. No store-bought shortcuts.
Nope. You have to design and build it from scratch.
It's a real test of engineering skills.
Absolutely.
And you can't just let it roam around freely, right?
Correct. The robot has to be controlled remotely from the launch point.
Okay, now that's starting to sound really challenging.
Yeah.
But it does level the playing field, doesn't it? It puts the focus on actual talent, not just who has the biggest budget for fancy parts.
Exactly.
Speaking of talent, I've heard about a team called Esort.
Ah, yes. They're a fascinating team.
They've been competing in Hungarians on Mars for a while now, haven't they?
Since 2008, I believe. And they're known for pushing the boundaries.
I read about their VR research project. Pretty impressive stuff.
Oh, absolutely. They're definitely a team to watch.
So we have the launching device, we have the robot, we even have a formidable competitor to look out for.
Yep.
But how do teams actually score points in this competition? Is it all about hitting the target, or is there more to it?
Hitting the target is important, but it's not the whole story.
Okay, I'm intrigued. Tell me more.
The target area has 6 black squares. Each one is 1.5 by 1.5 meters.
Okay.
And they have a white circle in the center. These targets are placed between 40 and 60 meters away from the launch point.
So there are multiple targets, and they're pretty far away.
Yep. Adds another layer of complexity.
For sure.
You get 10 points for each target you hit with your launched object.
Makes sense.
But each target can only be scored once.
Ah, so you can't just keep hitting the same one over and over.
Nope. You have to be accurate and efficient.
So strategy comes into play. You have to choose your targets carefully.
Exactly. And then there's a bonus.
Oh.
You get an extra 10 points for each target you're still holding at the end of the mission.
Oh. So it's not just about hitting the target. It's about holding on to it.
That's right. You need to think defensively as well as offensively.
This is getting really interesting. It's like robotic capture the flag.
It kind of is.
Okay, so how does the competition actually work? What's the format like?
Each mission lasts 30 minutes. 4 teams compete at the same time.
Wow, that must be chaotic,
It can get pretty intense.
especially with so much at stake.
Oh yeah, only the top 8 teams go on to the semifinals. Then the top 4 make it to the finals.
So you really have to bring your A game.
Absolutely. And teams can compete multiple times.
Ah, so you have a chance to redeem yourself if you mess up.
That's right.
Are there any penalties that can cost a team points during a mission?
Well, if you have to enter the field because of technical issues.
Like if your robot breaks down?
Yeah. Or if your launcher malfunctions, that will cost you time.
So you need to build systems that are reliable.
Robustness is key, and this is something that really caught my eye. The organizers are committed to holding the competition no matter the weather.
Really?
They even mentioned the possibility of snow. Imagine robots competing in a blizzard.
Wow, that's hardcore.
It adds a whole other level of difficulty and realism, I guess. You have to design your robot to function in any conditions.
So are we talking waterproof casings? Special tires for traction in the snow?
Could be anything. The teams have to anticipate the challenges and come up with solutions.
It's like a real-life Martian simulation, right? Unpredictable conditions, limited resources, the need to adapt.
Exactly. And that adaptability is a valuable skill, not just for robotics, but for any kind of engineering.
So, to recap, we have a challenging but rewarding competition. It demands creativity, technical skills, strategic thinking, and a bit of luck with the weather.
You got it. But there's another layer of complexity we haven't even touched on yet.
What's that?
The software, the brains of the operation.
Oh, yeah. We've talked about the hardware. But what about the software that makes it all work?
That's where things get even more interesting. And that's what we'll be diving into next. Welcome back to our deep dive.
Now we're getting into the real nitty-gritty of this Hungarians on Mars competition.
It's more than just building a robot. That much is clear.
Yeah, it's like a whole engineering challenge. Problem-solving, strategy, the works.
Exactly. You need so many different skills to succeed. It's not just about being a robotics expert.
So you need mechanical skills to build the robot, obviously.
Of course. But then you need the programming skills to actually control it.
And let's not forget the strategy involved. You know, figuring out how to outmaneuver the other teams and grab those targets.
It's like assembling a mini NASA team.
I like that analogy. Everyone with their own expertise working together.
Right. And you have to coordinate everything and make sure all the pieces work together seamlessly.
Which is a whole other challenge in itself. And let's not forget, no pre-built robots. You're building everything from scratch.
That's right. So you really need to understand robotics inside and out. The mechanics, the electronics, the software.
Okay, I'm starting to feel a little overwhelmed here. Is this competition really achievable for, someone who's not a robotics expert?
Oh, absolutely. That's the beauty of Hungarians on Mars. It's challenging, but it's also accessible.
So you don't need to be a robotics whiz to compete?
Not at all. There are mentors to help guide the teams, and the organizers even provide source code for the control system.
Oh, that's helpful. At least you have a starting point.
Exactly. It's more about the passion to learn, the willingness to collaborate, and pushing your own boundaries.
So you're saying even a beginner can jump in and give it a shot?
Definitely. And remember, it's all about ingenuity and creative problem solving.
Okay, that makes me feel a little better.
Good.
Let's talk about the robots themselves. With a weight limit of 5 kilograms and no drones allowed, what are the most important design choices?
Power efficiency is huge. You only have 30 minutes for the mission, and potentially rough terrain to navigate. You need to move quickly and efficiently.
No gas guzzlers allowed.
Nope. You need something sleek and nimble, built for speed and endurance.
Makes sense. What else?
Don't forget about the risk of getting hit by other projectiles. The organizer mentioned that specifically.
Yeah, like a stray tennis ball from another team's launcher.
Exactly. So you need to think about sturdy materials, shielding, maybe even evasive maneuvers.
It's not enough to build a robot that works perfectly in the lab. It has to be able to survive in a chaotic competition.
That's right. You need to anticipate the worst-case scenario.
And on top of all that, you have to factor in the weather. Remember, they're committed to holding this competition no matter what. Rain or shine, even snow.
Yeah, imagine your robot working flawlessly in your workshop, and then it breaks down in a blizzard.
That's a nightmare scenario.
It definitely adds another layer of complexity, and it makes it more realistic, too. Like a true Martian simulation.
Okay, so we have the robots, the launchers, and the unpredictable weather. What about the actual game strategy? How do teams approach the target area? Do they go for the closest targets first or try to block other teams?
Now that's where the mental game comes in.
I was hoping you'd say that.
The fact that you can only score each target once makes it even more strategic.
So you have to choose your targets wisely and anticipate what your opponents are going to do.
Exactly. Do you go for a high-value target that's further away? Or try to block another team?
And don't forget those bonus points for holding a target at the end of the mission.
Right. You need to be thinking both offensively and defensively.
This is sounding more and more like capture the flag with every detail you add.
It's got elements of that for sure. Plus King of the Hill and a robotic obstacle course all rolled into one.
So we've covered the hardware, the unpredictable elements, and the strategy, but we haven't really talked about the software yet.
Oh, the software. That's a whole other beast.
Yeah, the teams can control their robots and launchers remotely, right?
That's right. They use radio control.
So what are the challenges of developing the software for this competition? I mean, it's not just about making the robot move forward and back, right?
Not even close. And that's where we'll pick up next time.
And we're back. Time to dive into the software side of Hungarians on Mars.
This is where all the magic happens. Well, code magic.
Right, because you could have an amazing robot, but if the software is bad, it's not going anywhere.
Exactly. It's like having a Ferrari with a flat tire. All that power, but you can't even move.
Let's talk about the Hungarians on Mars challenge specifically. What are the software demands? We have the launcher, we have the robot.
Two separate things to control.
So is it one big program that controls everything? Or are we talking about separate programs running on the launcher and the robot?
That is the question. A unified system might seem simpler, right? But if something goes wrong,
It could be a debugging nightmare.
oh yeah, imagine trying to untangle Christmas lights, but they're all wires and code.
So maybe separate programs are better,
Mm.
even though it adds complexity.
It does, but it also gives you more flexibility. But then you need to make sure they can communicate with each other.
So we're talking about communication protocols,
Mhm.
like ESP Now, which the organizers mentioned.
Exactly, that's one option.
For those of us who don't speak fluent code, can you explain what a communication protocol does?
It's like a language, but for machines. It's how your launcher and your robot talk to each other.
So if the protocol is wrong, they're basically speaking different languages.
Exactly. Imagine trying to order a pizza, but you only speak English, and the delivery person only speaks Italian.
Chaos. I'd probably end up with anchovies on my pizza.
And in a competition like this, even a small communication error could be disastrous.
Okay. Real-time control. We're talking about actually piloting the robot live, right? Not just pre-programmed routines,
That's right. You need to react to what's happening on the field.
which is probably super challenging.
Oh, yeah.
Yeah.
Latency is a big one. That's the delay between you sending a command and the robot responding,
I can see how that would be a problem.
especially when every second counts.
And what about signal interference? I mean, the robot is going to be moving pretty far away from the control point.
That's another big challenge. The signal could get weak or even lost completely. So your system needs to be robust.
What can teams do about that?
Lots of things. You can use signal boosters, redundant communication systems, even clever coding tricks to improve reliability.
So you're basically teaching the robot to think on its feet a little bit, to have a backup plan if things go wrong.
Exactly. Which brings us to another interesting aspect of the competition, recapturing targets from other teams.
Oh, right. The organizer did say it could get a little chaotic out there. How does that play out from a software perspective?
Well, programming a robot to navigate and pick up an object, that's one thing.
But now we're talking about identifying targets held by other teams.
Exactly. And making strategic decisions about which ones to try to recapture.
It's like a little robotic war game AI.
In a way, yes. The robot needs to analyze the situation, evaluate the risks, and make decisions in real time.
That sounds seriously advanced.
It is. It pushes the boundaries of what we usually see in robotics competitions.
Now, I'm just a podcast host, not a software engineer. But all this talk of protocols and AI is making my head spin. Is it even realistic for teams to develop this kind of sophisticated software?
Well, the organizers do provide some basic code.
So that's a good starting point.
Right. But if a team really wants to stand out, they might need to go beyond the basics and develop custom software.
What are the trade-offs there?
The provided code is reliable. It's been tested. It's likely to work.
But it might not be as cutting edge as custom software.
Exactly. But custom code can have bugs. It might be less reliable.
So it's a gamble.
Kind of. Do you play it safe with the reliable option? Or do you take a risk and go for the custom software that could give you an edge?
That's the beauty of this competition, isn't it? It's all about those tough decisions.
Absolutely. It's not just about building robots. It's about real-world engineering challenges.
From the hardware to the software, and everything in between.
Right. You have to think about the big picture, the risks, the rewards.
You have to push yourself beyond your comfort zone. Maybe that's where the real breakthroughs happen.
Couldn't have said it better myself. And speaking of pushing boundaries, we have to mention the Assort team again.
Oh yeah, those guys. They're going to be tough to beat.
With their experience and their track record of innovation, they're definitely a force to be reckoned with.
Well, to all our listeners out there who are thinking about competing in Hungarians on Mars, we say go for it.
Do your research. Find a great team. And don't be afraid to think outside the box.
Who knows, maybe next year we'll be watching your robot on the Martian landscape.
Conquering challenges.
Achieving victory.
And maybe even winning that trip to, well, not actually Mars, but a pretty awesome 3-day trip nonetheless.
And that's a wrap for our deep dive into Hungarians on Mars. It's a truly unique competition.
A great example of engineering excellence.
Pushing the boundaries of robotics.
And inspiring the next generation of engineers.
Thanks for joining us on the Deep Dive. We'll see you next time.